With me today, I have Jason Stangel, as mentioned, from Slalom. He's a managing director with that group, and Mark Mims here, Google Solutions Architects. I was going to start off with you, Jason. Can you tell us a bit about you and what your role is in your organization?
So I've been with Slalom for about 6 years. I've been in data for my entire career. I started out as a product of the .com, so I'm old. So at Slalom, my role is really to create environments that people can really succeed in. And the environments that I help those folks with, or the teams that I lead, our data and analytics team, which includes data science, which is what we're here to talk about today, as well as our emerging tech team. And then I also run our alliances. So I work with the folks at Google pretty regularly in making sure that that partnership is really blossoming.
Hi, I'm Mark. I call myself a data plumber. Background in physics. I teach a class at Berkeley, part of the data science program, just enough data engineering for the data scientists to be successful in the program and in their careers. And I work at Google, part of Google Cloud, helping people use cloud to, help basically data engineering pipelines on Google Cloud of all kinds across all industries and specialties. So.
Great, thanks guys, and we're very happy to have you here. Can you tell us about some things, Mark, that you do to help your clients get started with AI?
Yeah, getting started with AI, one of the most important things we do is recognize that solutions that are AI specific aren't all that different from any other solution. So we make sure we keep it close to the business, close to the problem. It's really easy, especially with AI, to go down a rabbit hole and be interested in the AI for the AI itself. And you have to really fight that when you're trying to actually solve real problems associated with it. So, so that's the first thing, and I think.
Yeah, please. Since we're passing the mic, we just have
to
make the rounds.
Calling audibles. So at Slalom, we like to focus in on outcome. So we help our clients really identify the outcomes that they're trying to achieve. We then either help them create a strategy in order to achieve them, or in a lot of cases, we help them create a center of excellence so that they can do it themselves. Or we will come in and do proof of concept type work where we're doing it with their teams so that they can learn as we're building those proof of concepts, all the way to folks will come to us and say, hey, we've got these 3 data science problems or these 3 AI problems, and we really need them executed. We need them executed quickly, and we need them done at very high quality. And that's something that we do for a lot of companies around town.
Yeah, and speaking of centers of excellence, many audience members here might be thinking, how would they start with setting up an AI center of excellence? And they, getting more out of maybe even their existing AI functions. So tell us a little bit about what your thoughts are on how to get started there.
Sure. So I like to think of COEs, there's lots and lots of ways to implement a COE, but they kind of all boil up into 2 primary types. One is a center of enablement, and one is a center of enforcement. And we think that the center of enablement is a much better way to set up your center of excellence. And what I mean by that is a center of enablement would focus in on creating assets, creating templates, creating frameworks, education, and then working with the business and actually embedding into the business in order to solve some data science type problems. On the other side, the enforcement folks, they're more about control. And they want to bring it in, they want to own data science, or they want to own AI and ML. And they bring all of this in, they have a really rigid intake processes. Once it gets in there, it gets in this huge long backlog. And then the business thinks, well, nothing's getting done. We start to lose confidence, and then we end up with shadow AI all over the place.
So, yeah, I guess I'd like to add to that we really encourage people to develop a discipline of model management and to recognize, first of all, the first thing out of the boat is to recognize the limitations of models, period. Whether they're analytical models you had from forever, numerical models, some approximations of either of those, or whether they're a deep model that you've just kind of thrown at it, you really need to recognize that they have limited range of applicability. So that's the first thing, is to recognize the limitations there, and then to start working around them. So to develop a discipline of model management that includes asking questions like, okay, is there a way to determine the validity or the correctness of this model? Is there a way to get reproducibility out of what I'm getting, out of the results I get from this model? Is there a way, just different means of operationalizing the models that you're using? That's critically important. Understanding failure modes and things like this. So it's kind of, again, developing a discipline associated with model management in general.
That sounds a lot like software development, right? And so,
yeah. No, that's actually one of the something that I recommend we do. In that I've actually been talking about this for a while at different conferences, and it's getting less and less of a surprise to people. But I'd like to start stealing ideas from the software development industry. Things like test-driven development, behavior-driven development, they are, you get a kid out of school, they're totally already immersed in that discipline. We should be doing that for data engineering and data pipelines as well. Declaratively specifying the expectations of your pipeline, being able to characterize what's going wrong, being able to throw different kinds of tests at them. Sometimes those tests are going to be formalized tests. Sometimes they'll be gating tests. Sometimes you'll just be tapping the stream as it goes by. Maybe doing a render of it so you can actually do a wetware sanity check. It's still testing of, it's still developing that discipline of testing, and that's I think critically important to the industry, and it's something I'd really like for people to start, embracing more, please.
Sure. And one of the things we talked about too is the importance of measuring your outcomes, right? And so I think those are all great points. In general, some people are doing this better than others. And so what industries do you see are really taking a hold and implementing AI and ML in a way that's, the best of the breed? And then why are some of the others struggling, in your opinions? I'll start with you, Jason.
So the obvious ones are the technology companies, right? Facebook, Google, Amazon. Those guys are way out ahead of everybody. I think I saw some statistic that 38% of all technology companies are investing in AI and ML, which the next best one is like 3% of that industry. But if we focus in more on Denver and what industries that are really here and where we're seeing a lot of traction in our clients is really around telecommunications, media and telecom. We're seeing it around marketing agencies. And really any company that has a big marketing function. People want to know more about their customer. They want to know what their customer is going to do next. They want to know how to better market to their customer. We're seeing a lot of traction there. And then finally, financial services. There's a lot of uptick there. But the really interesting one is healthcare. You wouldn't maybe guess that healthcare is on their way up, but we're seeing some incredibly novel and really useful use cases within healthcare, and I think that they're probably going to catch up here pretty quickly.
Yeah, I think I'll take what's been preventing people from embracing AI or what's in the way of embracing AI right now is your ability to operationalize your data pipelines again. And that's actually it, honestly. I mean, that's a big statement, and it involves all aspects of the organization. But there's just so much opportunity, there's so much potential once that's embraced, once that's made, decision has been made.
Very good, guys. And I'd like to hear, yeah.
Do you see the data scientist groups or the people that are practicing AI reporting up to the CIO usually, the CDO? I heard marketing, so the CMO is CIO usually have oversight over those teams, or?
Great question.
You want to take it?
Sure.
You go first. I'll go
Right, so traditionally you've been busting into sort of like the data engineering side that then provided various different services to the data science groups. ML gets thrown into all of that. And that divide's been very clearly in a lot of organizations, AI or IT versus the business groups. The business groups have been sort of sponsoring and initiating a lot of the engagements. But then they're baffled when it comes time to interact with engineering and IT. And the change, and this is really what precipitated the course that I teach, is that data scientists are expected to bring their own engineering nowadays. And so as part of any data science training should involve a lot of engineering. There's
what
quite
number
a bit
do you
of
think that is? We hear different numbers. How much of a data science project is truly
I don't know. I wouldn't guess. Not enough.
So I'll go back.
95.
Yeah, in our view, it's usually in the 80s somewhere. But I'll go back to my previous comment around the center of enablement or the center of enforcement, and where we see the best data science programs, the best AI programs, are when you have a data science team that's really embedded with marketing, and they know marketing very well. You have a data science team embedded in finance. You have a data science team embedded in the different parts of the organization that are then being supported by a center of excellence, and all of the standards are being created around. So the answer to your question is kind of yes. It's reporting all over in the organizations. We see a lot of CMOs having data science teams. We're also seeing more and more companies in Colorado having chief data officer, chief data and analytics officers, where they'll have the center of excellence underneath them.
Can I add something?
Sure.
I'd like to add something to that. Just the concept is data-driven decision support, right? It's businesses driven by quantitative decisions. So the business component should be what owns that, and the tooling should support that. And we're trying to do that, right? Cloud providers, various tooling vendors, integration providers, everyone's working to try to support that activity. And I think that's the end goal, at least as I understand it, is to empower the business user themselves to not rely on a lot of additional, resources to have to make some of these decisions that they're making. And whatever those models look like, whether they're AI deep models or whether they're strict, cleaner machine learning models or something, doesn't matter in that context.
Great. Thanks, guys, and great question, Julie. Anybody else, if you have anything you want to jump in with? Yeah, oh, please.
I might need that.
Yeah,
Maybe
there you go.
not.
I can get off my chair, it's fine.
So when you say data science, that's a big word for a nonprofit or small business or mid-sized business. How do you make companies of those sizes or those types feel like I know data and I know it well, even though I don't have a data science title?
Go ahead first. Definitely would answer.
So I think I understand the question is how do we enable these non-enterprise customers to really have data science or AI ML embedded within their organizations? Did I get it right?
Yep.
And there's lots of ways to do it. There's lots of out-of-the-box models that are available for people to take on. There's lots of support groups that are out in the community. There's lots of firms like Slalom that you can call and we can help.
Nice plug.
But there's also a lot of different approaches that you can take in order to achieve data science-like results. AI and ML is not always the answer. Sometimes regular old regression analysis will work, right? So there's lots of different ways to go after it. But I think your answer might be better.
I don't know better, but the barrier to entry is really low right now, and it's getting lower, and that's exciting, right? The tools that are available to do this, and I hate to make this a product plug, but there's a couple of products that I'm using for class as well, like AI platforms notebooks. It's crazy the amount of engineering that's made available to you as an end user in the click of a button. And it's just, again, that's just moving more in that direction. Similarly to the notebook and exploratory area, there are also tools like AutoML or AutoML tables that you don't really have to know anything about the particular choice of algorithms and things like that. You throw data at it and it kind of tries a shotgun approach and sees what kind of fits best. It gives you that back to you. But there's a lot that we're turning over to the machines in that regard. So put in extra checks of robustness and extra checks against your business logic to handle that, to make up for that. But there's just a lot of power in that. And again, its barrier to entry is just really low. So.
Awesome, thank you. Yes, great crowd participation there. I know, Jason, you were telling me about a pretty cool thing that you guys did, and talk about something where you've helped an organization do something interesting with AI, please.
So I learned today that October is Breast Cancer Awareness Month. I probably should have known that, but so I'm going to talk about breast cancer. Slalom and Google, actually, we partnered together, and with the American Cancer Society to help physicians and researchers better understand breast cancer. So we took images from mammograms, millions of them, and we used unsupervised, I can never remember that word, an unsupervised model, thank you for helping, an unsupervised model to really find the patterns within those images. And we did this over, like I said, millions and millions and millions of images, and what we found was these new and novel patterns emerged from the data that humans couldn't see. And some of those patterns showed that there was a higher mortality rate if this pattern happened. In other cases, it showed that different courses of treatment would be more effective. So what we've done is a lot of this work to find the patterns. And now the next step is to figure out, now that we have the patterns, how do we make the recommendation engine that goes and tells the physicians what their next best course of action might be. It's kind of a feel-good story.
You got one?
No.
Okay.
I was just passing it back.
It's fine. Let me ask you then, Mark, what do you see as something super cool and interesting about the future of AI?
So yeah, there's just, I don't even know where to start or end with this, so be careful what you ask for. Yeah, right, well, we'll work on that. So one of the things that I'm really excited about right now that we're seeing relatively new activity in is what I consider scientific AI. It's taking disciplines where there were pretty strong models, pretty strong analytical models available, numerics. And the cool thing about this is working with some of these customers, we can actually talk about what they do. Like CERN, for instance. They're trying to reproduce particle tracks and things like this. They're trying to, the next run is going to generate a petabyte a second of data. I know, right? So what do you do with that? You throw it on the floor, but you got to pick something up. And so the idea is to use deep models on edge in the detectors to make more intelligent decisions about what to keep and what to throw away. That couple, of course, with with more central data models of the data that has been acquired to then do particle retraces and things like that. But I guess the point of this is that any device modeling for health you might be doing, any epidemiological modeling you might be doing, any some of those are sort of obvious statistical answers, but we're now starting to use deep models to pursue domains that are not just statistical in nature. So, for instance, if you have physiological-based pharmacokinetic modeling, where you're modeling toxicity absorption into tissue or something like that, all the equations that are used to generate those, or that are those models, can be replaced by a deep model. So it's really an exciting time in that. It's dangerous, of course, and this is where it comes back to the earlier point of operationalizing this, right? So we take when you take your careful mathematical model that's developed over centuries, perhaps, and you replace that by a deep model overnight, what are the ramifications of that? We've talked about explainability in the community, and I actually start thinking, in a lot of cases, those analytical models were just models. They're not reality, and they're different from reality, and you have to do various different things where you check that against reality. You then take a numerical model, which is an approximation of that, and you often do a horrible linearizations of that. So you're in your quote-unquote explainable model, you're actually pretty far from reality at that point. So what's the difference between that and a black box deep model that can generate the same results consistently when it's wrapped in an operational framework that you can develop, you can reproduce your results, you can test your results, you can identify the extent of support of those results, right, or the model. I think that's a really exciting area to be in. So that's one. The next one that I'm really excited about, the next one I'm really excited about, we can swap back for so. So what's called in popular literature software 2.0, where it's less that we're hiring developers to write software. It's more about we're hiring developers to wrangle data to feed models that write software. So we might never see that edge software being written, or that edge software that's written, nor might we care as long as, again, it's put in this framework of testability and reproducibility. So I guess that's probably a big message there, is that we have a lot of things, I think, in process that the community is working towards, some of which is more dangerous than others, depending on how you use it. So it comes back to a really important point to be responsible and operationalize the pipelines we're working with, so that we work within safety parameters, right? If we're using it to fly a model helicopter thing, put in the gimbal locks, right? Make that part of the framework that's used to test and train that model. That's important. I could go on all day.
Jason, I'd like to hear from you. What are you excited about with AI in the future?
Well, I've got a person on my team who's trying to coin this term, which is ambient computing. I don't know how novel it is or not, but what this concept is, that everything digital that we have is going to have AI and ML in it. Almost everything physical that we have is going to have AI and ML in it. And our experience as humans, living our day-to-day lives, is going to be integrated with AI and ML. And that's going to make our lives more convenient. That's going to make experiences in a place like this more interactive. And I think that's really exciting to see how it's going to really integrate with our lives in a non-creepy way.
In a super non-creepy way, I want it to interact with our lives is to just write ETL for us. And if it can figure out how to code itself, then then I'm a happy guy. At least I think there's probably a few in this room too.
Declaratively specify your ETL in certain ways and then have that be generated. That'd be cool.
Yeah, Mark, we have 30 minutes.
Yeah, sorry.
So one last point, I want you guys to drop a quick knowledge bomb on the group of how would you suggest they get started with their AI journey? So Mark, I'll have you start here.
Probably the biggest thing I'd say is demand more from your vendors and your integrators. They should not be feeding you tools that don't provide this operationalization capability. And that's, I say that somewhat tongue in cheek because we're not there yet as an industry, but we're moving in that direction. And the way we move in that direction is if you as the market start demanding more from the tool vendors and your integrators.
Totally agree. The operationalization, it is a tough tongue twister. It is really important. We see so many models that get built and then just sit there. Maybe a Tableau dashboard got put on top of it at some point, but it doesn't actually make it into production and become part of the business process. My thoughts is really around that AI and ML is not only a technology problem. It's not only a technology solution. I think that leadership in organizations is really going to have to evolve and understand how to take advantage of this new technology. And I think that they're going to have to understand that their whole organization is going to transform as part of this process. And so is every single person that works with them. They're going to need new skills. They might have new roles. They might be afraid that their jobs are going to be on the line. There's a lot of change management and really people side of things that's going to have to be taken on. And I think the companies that forget about that are really going to struggle.
Yeah.
Mm-hmm. Totally agree. It just can't be an unsupervised model in that respect, right?
If I could remember the word, maybe.
All right, we had a little bit of participation. Anybody else have any question for my illustrious panel here? Yeah, over here. I'll do the running thing again.
Thank you. So you mentioned AutoML and using this as a tool for coming up with baselines. I'm Martin, by the way, I'm from DaVita. I'm actually one of the folks implementing this stuff, declarative pipelines and all that. But the question is, do you see AutoML taking the role of a junior data scientist in terms of coming up, trying a bunch of things, coming up with a baseline, and then establishing what's possible, and then building from there?
Thank you. Yeah, so we talked a little bit about software writing software, but this is a different bent on that.
Yeah, I think I'd put it more as a tool for a junior data scientist. There still needs to be integration, right? The distance between a business question and a query, for instance, is huge, right? So you still need people who are putting that together. I don't see that going away anytime soon. But I do see that these are tools that empower those people to explore and perform more of an exploratory analysis associated with what they're doing. It's things like in class, I sort of harp on them to never take a data set at face value. It might be labeled .xsl, but it's actually CSV. So do some back of the envelope calculation initially, and we spend a lot of time with shell commands and things like that to just get an envelope before we use it in a model and find out, months from now that, whoops, we made a huge mistake. So those back of the envelope calculations, and that's something that AutoML is a perfect tool for, and can help with that process. So no, not replacing augmenting, honestly, and not just because, not for, whatever political reasons, but yeah, the best tool for the job is AutoML in that case, and a brain for the other part. We're not there yet.
Yeah, some cognition for sure.
Yeah, cognition,
Okay.
wetware.
Anybody else? Yeah.
Do you guys see organizational silos getting broken down for data? What I see is there's a lot of data in different organizations that really help build these models out in a robust way. From a consulting perspective, are you guys seeing the sharing of data from engineering to marketing to sales?
Our runners fall asleep on the job.
My legs are falling asleep, actually.
Yeah.
What we're seeing is that companies want to get into doing AI and ML, and then they realize that they had all these silos and that they need to break them down. But as we are working with these companies, we're seeing more and more sharing. We're seeing more and more cross-pollination of information. The big problem that we're seeing, though, is that they don't have the tooling and they don't have the data organized in a way in order to make this possible. So we end up spending a lot of time building data lakes and building data warehouses to get this data together so that we can do that sort of work. Did that answer the question?
Yeah. Well, I just wanted to see what you're saying.
That's why.
So far we are seeing AI making a lot of progress with vision and textual stuff, where the data distributions are more static, right? They are not dynamic. But in case of healthcare, for example, like monitoring heartbeats, heartbeat scale, there have been some progress, but a lot of healthcare data, there are a lot of dynamical systems, right? Dynamical distributions, or even in finance, say, financial markets. I'm not seeing that much of success of AI, let's say deep learning, right, in those areas. And there's still a lot of innovation required there. I'm just curious, since you are from a healthcare company, right? If I'm not wrong.
Google.
Oh, Google. Sorry. Yeah. So Google is doing
Yes.
So I want to say.
I'm sure there will be later.
Even later. So if you're from Google, so I'm really curious to know where you see the future of deep learning or AI in the dynamical system space.
Sure. Yeah, so neural differential equations. So there's an idea of neural networks with layers that are getting more and more layers that are getting closer and closer together. Looks more and more like a continuum. So that's
best paper in Mims, right, last year.
yeah. Right. So I beyond that, I don't know. I know we're working on it in a lot of different areas. Just in working with customers. I'm sure we're working on it on stuff internally with respect to like Google research and stuff like that. I don't know, but with customers, we're definitely working on that in the context of differential equations. So.
I'm sure WebMD is trying to figure out a way to make a chatbot make you very paranoid about what's going on with your body, right? So there's that too. I see a question there.
So Mark was talking about the availability of different tools to get started with AI, ML. We talked a little bit about the best starting place, but what do you see are some of the most common pitfalls or where people run into issues as they're beginning to embrace AI and ML more regularly?
My favorite one is, I got this pile of data, can you do something with it? And I'm serious, customers come to us all the time and say that we want to dip our toe into AI and ML, we want you to build an ML model on this data. And we say, what problem are you trying to solve? And they're like, we don't know. We want you to tell us what problem we can solve with this data. What I'm really trying to go with this is the best thing that you can do is find a real problem that has real value to go solve, and then figure out if you have the data to go solve it. And if you do, then you can go down this path. But really focusing on the outcome first, what are you trying to do, and then figuring out how to do it is a much better approach than just trying to shotgun it.
I don't know why that's so difficult for people to embrace. Like the basic process you just described there is perfect. I love that approach. I just don't, it's really hard to sell sometimes that, hey, look, we really need to start with what we need out of this before going all, hog wild on the various different technology options. I love the technology options, don't get me wrong, but if you're, there's got to be a reason. And so, yeah, that and data quality,
The kind of counterpoint of that is I've seen a lot of companies that in the process of business gather a lot of data, but they aren't really they're really not sure exactly what to do with it, and that's why they end up coming to the data scientist and asking that question. So in that kind of situation, because let's be frank, that is going to come up a lot, how would you approach that?
Do you want to hit it?
You go first.
Okay.
I went first last time.
I'm sorry, I forgot the question. I had an answer.
So how do you get over this challenge of coming up with the use case first? Like, how do you work with the business, right? Is that your question?
So
that does happen a lot. It does. So how do we handle it?
So in my view, that is a data science type question. Tell me about the data that I have. Tell me what I might be able to do with it. Help me catalog it. Help me understand it better. But that is not build me a model. That's a very different kind of a project or an approach, which is you can do analysis on that information. You can find out, hey, I've got these domains of information at my disposal. I have these relationships between these different domains of data at my disposal. Mr. Business Person, Miss Business Person, tell me about the biggest problems that you're trying to solve or you're facing in your work, and I can tell you if we have the data to support it. So trying to avoid going straight to model building, because model building without an outcome is like, it's just guessing.
Well, at the same time, data scientists oftentimes have to be a little bit of other things too. A little bit data engineer, a little bit business analysis.
That's what I was going to say. This is where your unicorn data scientists come in. And what really distinguishes one effort from another is your ability to recognize what's relevant to the business and map that to the data and back and forth. You do have approaches like financial industry, unfortunately, has this bad habit of, and it's traditionally had this bad habit of, I'm going to try one of everything. I'm going to try a shotgun approach. And that's fine, but what happens often then is they sort of like, oh, I'm going to eyeball it and average what's resulting without recognizing that that's a portfolio and you just took the volatility of your result and magnified by all the volatility of all the inputs. So you can't trust the results that come out of that. That's a bad habit. However, from an exploratory standpoint, there are tools, like I was saying, the AutoML stuff, where it just kind of does try that shotgun approach of try everything and just kind of see what comes out of the data from an exploratory standpoint. But like Jason said, that's not model building, model development. That's sort of part of an exploratory part. And honestly, I'm not sure what the best way to slot that into your disciplined model management approach. That's kind of preliminary to that, I would guess. But I bet it's part of an iterative process that you would have to define for that. So, good question.
So unfortunately, I got to move the agenda along. Thank you, Jason, Mark, for your time and your insights.